Started encoders. Encoder is what? Encoder is used for converting from one format to another format. Encoder is used especially for data compression. The encoder is used especially for data compression. The input for encoder will be, for in this case, the same example I want to take. The input for encoder will be 8. From that 8 inputs, it is generating 3 output. Okay. So this 3 outputs is like data. Previously the data was 8. Now it is compressed to 3. Okay. So encoder is especially used for data compressions. Encoder is specially used for data compression. So what is the use of data compression is, if you're going for data compression, instead of storing 8, you are storing 3, so memory space will be reduced. So the main concept of encoder is the input will be more. So you can consider the inputs as 2 power n and output as n. Okay. So in this, why there is a need of going for encoder is for data compression, for storing, for saving the memory space, where your the application for this you can consider as data compression. Okay. So you're converting from one format to another format, like the one format can be octal. So this can be considered, this question can also be asked as convert octal to decimal encoder. Okay. Convert octal to decimal encoder. Okay. So not decimal, binary. Okay. So if it is binary, what you will be getting, ma? Octal to binary. So octal representation in binary will be using 3 bits. So that's the reason the output is 3 bits. Okay. So we are in encoder. So the encoders is used for converting one format to another format, and the format will be, we are converting from the 2 power n to n, and again we are using what? Decoders for converting these n bits to the actual format 2 power n. Okay. So now before going for decoders, let me complete encoder. So we started with priority encoders. First question is, why there is a need of studying priority encoder is, so we have an encoder where, let me take 4 inputs. 4 inputs means this is 2 power n. What will be the n ma outputs? How many outputs will be there? 4 inputs
Two,
means
ma'am.
2 outputs. Okay. So 2 outputs, you will be having 2 outputs. 4 inputs, 2 outputs. Okay. Now there is one rule called, among 4 inputs at any time only one will be high and remaining will be 0. Only one input will be high and the remaining will be 0. Okay. Only one input encoder concept. First encoder concept is, among n to power n number of inputs, only one will be high at a time. Okay. But what happens instead of one if there are more inputs high? So we have 4 inputs. If there is 1, 0, 0, 0, no problem. Only one input is high. This input will be passed to output, and you will be getting, if it is this one is D0, then you will be getting 0, 0. No issues. So this is normal encoder. But what happens if instead of at a particular time, instead of one input high, if there are 2 inputs high? Okay. So let me consider D0, D1, D2, D3. So in this D2, D0, D2, D3, 0, 0, and D0 as 1 and D1 as 1. So which one will be considered as output ma according to priority encoder? Which one will be considered
D1.
as D?
One, ma'am.
D1. So you will be getting output 0, 1. So this D0 will be considered as don't care. This D0 will be considered as don't care. So when we will go for priority encoder, we know that when you are using an encoder, so among n number of 2 power n number of inputs, only one input will be active at a time. So, but in some situations they happen that more than one number of inputs are high, then we need to go for priority encoder. So in priority encoder, D3 will have a highest precedence, if it is 4 by 2. Let us consider if it is 8 by 3. D8, D7, sorry, we are starting from D0. So D7 will have a highest precedence, then D6, then D5, the least is D0. Okay, the least is D0. So if this is high, this remaining all will be considered as don't care. The remaining all will be considered as don't care. Okay, so we started with this, but this has to be completed by you. Now let me start with 4 by 2 priority encoder. In this case, when you will go for priority encoder, if at a time more than one input is high, so then we need to give a priority. So according to this, D3 will have a highest precedence, D0 will have a least precedence, and next D1, D2. Okay, so this is your, we started until here. And if D1 is high, D0 will be least, don't care. If D2 is high, D1, D0 will be don't care. If D3 is high, D2, D1, D0 will be don't care. Until here we discussed. Now we need to find out A0, A1 expression. So for finding A0, A1 expression, how many variable K map I need to select? That depends upon how many inputs that we have selected. As we have 4 inputs, we need to select 4 variable K map. Okay. As we have 4 inputs, we need to select 4 variable K map: D3, D2, D1, D0. Okay. Let me show, I will show in this case only D3, D2, D1, D0. Okay. Now concentrate, concentrate, you must know. So see here, the output, let me start with A1. So we need to consider this expression for A1 and A0. So let me go start with A1. So A1, wherever the output is 1, we need to consider. So in these two situations, we have output as high. Okay. So in these two situations, we have output as high. Concentrate. So for which input the output is generated high? For which input? D2 is high, right? So D2 is high. So think about, you look into this D2. So where is D2? D2 is the second in these two combinations. This part is D3. This part is D2. Okay. So now when A1 is high, when D2 is high, you are generating A1 as high. So see D2 where is high? You have here D2 as high. This is also D2, here also high. But among these two, which combination you have to select? Based on this combination, D3. So you know that when D2 is 1, D3 is low. So will you take two combination or only this combination?
Only one combination.
Yes, only 0, 1. So where D2 is 1 but D3 is 0. So I have considered this combination. Okay. Now see here, now what about D0, D1 and what about D0, D1? It is don't care. Okay. So these two are don't care. So if two combinations don't care, so how many combinations you will be getting? 2 as don't care means 2 combinations means 0, 0, 0, 1, 1, 0, 1, 1. So these are all don't cares. So here for D1, D0, we have 0, 0, 0, 1, 1, 1, 1, 0. These are all don't care. So we need to concentrate only on D2, 1. So we have 1 here and we need to concentrate on D3, which is 0. So this is a case. Okay. And this are don't care. Even if it is 0, 0, 0, 1, 1, 1, 1, 0, it is don't care. So what we are doing? And what we are doing? We are placing what? 1, 1, 1, 1. This is over for this one. Let me go for the other one in A1. So this one. What I have to check my fast? So this output is high for which input? For input
D3.
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 So D3 is high. So if D3 is high, so this is, where is D3 in this K map? This is your D3, means most significant bit. So you have two combinations, 0, 0, 0, 1, 1, 1, 1, 0. In this case, this one is your D3. Okay, this one is your D3. So here 1. So in this case also you have 1. In this case also you have 1. But which one to be selected? 2 have to be selected or only 1? Only 1 I have to select or 2 I have to select? Think about the rest of the numbers what we have. So it is showing as D3 as 1 and the remaining all are don't care. So we have don't care three combinations x x x. So don't care, you try to combine all 0 0 0 1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 101 like that, all will be don't care only. Okay, means even d2 is 0 or d2 is 1, we are least bothered. Why? Because these all are don't care. So if this is 1, d3 is 1, what we will be doing, we will be placing 1 in this place. Here also d3 is 1, we are placing 1. Understood how we placed in 4 variable k map for output a1 high ones? Everyone, is it clear?
Yes, ma'am.
Others also please respond.
Yes, ma'am.
Now, only two? Only two are there in the class? What ma? Only two are present in the class? What? Understood how from priority encoder, we have generated a K map for A1. So everyone understood where we are placing ones?
Yes, ma'am.
Yes, ma'am.
Okay. So in this case we placed ones. Now we need to go for grouping. So how to group man? So maximum you need to go for 16, but 16 is not possible. Next is 8. So we are grouping 8, this 8 and this 8. And tell me the expression for this 8 group man. What?
D2 plus D2, ma'am, first one. Second one,
First,
D3.
yes, good. So this is D2. This is what? D3. So we'll be getting the expression as A1 equals to D2 plus D3. We'll be getting expression as A1 equals to D2 plus D3. Now the same I don't want to show for A0. Let me complete here. Now I completed for A1. Now I need to do it for A0. May anyone tell me where I have to place ones? Hmm. See, so I have to check this is completed. Now I have to check A0. In this, we have one here, we have one here. So which one to be selected? Why this A0 is high? Based on the input, D1 is high. So as D1 is high, we got here high. So where I have to check? Where is D1? Where, this is your D1. So, you
Enough.
have to check this one and this one. Okay, both should I check? Only one combination, both I have to check. Why? Because we have only one don't care. So if don't care is, you may either get 0 or 1. So both will be don't care. So I need to concentrate on D1. So in these two positions, D1 is here 1, here 1. So I'm placing here as 1 1. Okay, next for this case also, for this case we have A0 is high when D3 is high. So D3 means we already discussed for A1 also. D3 is this one and this one. Okay. And should we see about D2, D1, D0 values also? No. Why? Because D2, D1, D0 are don't care. So directly you can go for D3. If D3 is high, then we are least bothered about D2, D1, D0 as there are don't care conditions. So where I have to place one? Yes, this is your. Tell me the expression. Can anyone? How to group this? This 4, 8 can be grouped to one group. And what is the expression for this? What is the expression for this group?
D3.
Yes, this is D3. Next, how to group this? The next group, how to group? D3. Next we have here 1 1. What to do? Should I group 2?
4, ma'am.
4,
4.
ma'am.
So yes, good. So this 2 and this 2. What is the expression for this?
D3, D1, ma'am.
See properly, no? You need to check this side. See here. You need to check this side and this side and the above 2. Tell me the expression you see from here. Let us consider this 2. You need to check this 2 and this 2. Emotion expression.
D2, D1, ma'am.
D2, D1. D2, is it complement or D2 actually? What we have here? 0. 0 is represented in complement or in normal?
Complement.
Complement.
So what will be the answer? What will be the answer?
D2 complement D1.
Yes, good. So the answer will be D2 complement D. Sorry, you will not be having D2. So D2 complement D1. So you will not be having complement if there is 1, but as we have 0 common here among these two 0, 0, so you will be mentioning as D2 complement D1. So this is your expression. See here. So this is a truth table. So K map, this is a truth table. This is your K map for A0. So what we have done, we grouped this 8 as one group and we got D3 and we grouped this one and this one and we got what? D2 complement. Why? Because in this case 0 is common here, 0. So this is D2. So D2 complement, and in this case D1. So D2 complement D1. So you are getting D3 plus D2 complement D1. Okay. So now I will see who will complete the next step is what? After completing the Boolean expression, next step is what?
Logic diagram.
Yes, logic diagram. So logic diagram, you will be having one for A0 and one for A1. And for A0, you are having one gate called AND gate and you are having OR. Okay. So this is your logic diagram. So instead of here A0, so see here, instead of your A0 and A1 here, it is showing as Y0 and Y1. Okay. So D0, D1 is same as it is, but in this case, it is in the block diagram, it is mentioned as Y0, Y1. This is a case. So what we have, as we have AND here, we used AND with the D2 complement. So this is your D2 complement and D1, D2 complement. This, let me write this clearly now. This is D0, this is D1, D2, D3. Okay. Now tell me the expression for Y0, ma. So Y0 equals to D3 plus D2 complement D1. Is it correct?
Yes, ma'am.
Okay. So for this, first we will go for AND. So for doing AND, for what we have to select D2 complement. So this is your D2 complement and the other one is D1. So this is your D1. So both are connected. We got AND. Next is what? Next we need, for getting Y0, we need to connect D3. So this is D3 already connected for 1. So we are taking this. So one side you will be having D3 and the other side you will be having D2 complement D1. So this is your output. Now coming for Y1. What is the expression for Y1, ma'am?
D2 plus D3.
D2 plus D3. So this is your D2. So we need to connect this D2. This is your D2 and this is your D3 and this is your Y1 equals to D2 plus D3. Okay. So this is your logic circuit. Okay. This is your logic circuit. Now This completes your priority encoder. Now, let me go for 8 by 3 priority encoder. Okay, let me go for 8 by 3 priority encoder. Complete K map, man. So we will be discussing about this priority encoder, but priority encoder among those all, the important is 4 by 2 priority encoder. Next, let me show the other cases. I completed this one 823 encoder.
Yes, ma'am.
Okay. Now tell me, we started with encoders. There are different types of encoders like priority encoder, decimal to BCD encoder, octal to binary encoder, hexadecimal to binary encoder. Among these four, tell me how many topics completed till now.
3, ma'am.
What are those three? We completed priority encoder. Okay. And one more it is completed among these three. What are the, which one is that?
Octal to
Octal to
binary.
binary.
Yes, Margot. Octal to binary. Next, we need to discuss decimal to BCD. So for that, listen all of you, before showing you the what is the concept. First, tell me, decimal means what is the base for decimal?
10.
10. So consider encoder by default it will be 2 power n, but in some special applications you can even go for 10 inputs. There is no issue. Okay, so as the we are specially implementing encoders for decimal to BCD, the input for encoder is what? 10 inputs. Why 10 inputs is we are considering this side as decimal. If you are considering this side as decimal, it will start from 0 to 9, 10 inputs. And what will be the output, ma? BCD is represented in how many bits? BCD is represented in how many bits?
4 bits.
4 bits. Now I will ask you anyone one question. If it is 8 decimal number, what will be the output of BCD? If it is given input 8 as high in input decimal, what will be the output of BCD? It will be
1000.
100. Yes, good. Now, see here, everyone knows that BCD is represented with 4 bits. So, the input for this question is you will be having 10 inputs and 4 outputs. Until here, it is clear, right? So, let me go for the example. This is your decimal to BCD. I will ask you one question. I will see who will answer. This is the same way that I explained. So one side will be decimal input, the other side will be BCD. So we are converting, means one format is what decimal you are converting to BCD. Again in decoder, what we will be doing, ma'am? Converting back BCD to
Decimal.
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 We will be doing that in decoders. But let me concentrate on encoders. So is this truth table okay? So the truth table is given as 0, 1, 2, 3, 4 until 9. And if it is 0, it means it is directly showing if 0 is high. Only showing the one which is high. 0 is high in this, so the output will be 0, 0, 0, 0. If 1 is high, the output will be 0, 0, 0, 1 like that. So I explained in this way only. 8 by 3 encoder. What will be the truth table, ma? Everyone written in your notes, I know that. What will be 8 by 3 encoder completed, right? So how you have written the truth table? Have you written like this? Truth table 0, 1, 2, 3 until 7 as
No, ma'am.
huh?
D0, D1, D2.
Yes. So in the same way you have to represent. Good. So this is your truth table for decimal to BCD encoder. This is your format. Okay. So this is your input. Concentrate. I will ask you the questions. This is your output. The input is decimal. The input is decimal, and the output is it decimal? Yes. Input is decimal, and the output is BCD. 4-bit combination. y0, y1, y2, y3. Okay. Now see here, ma. Initially it is showing as 0 in this case. 0 means that indicates among all 10 inputs, 0 is high. Directly it is showing. But in this case, you should not show like that. The 0 is high and remaining all are low. Okay. That means the output will be what? 0, 0, 0, 0. That indicates among 10 inputs, D0 is high. So among 10 inputs in this case D1 is high. Among 10 inputs in this case D2 is high. Means whenever it is high, the corresponding output you will be getting. So if D1 is high, you will be getting 0, 0, 0, 1. If D2 is high, you will be getting 0, 0, 1, 0. If D3 is high, you will be getting 0, 0, 1, 1. If D7 is high, you will be getting output as 0, 1, 1. If D9 is high, you will be getting output as 1001. Okay. In this case, you're not going for priority. You know that there are 10 inputs. In that, at any time, only one input will be high. So based on that, you generated a truth table. Now, tell me the expression for y not. Tell me the expression for y not. I will select one roll number. Tell me the expression for y not. You know that, right? So number of ones you need to select here. This one, this one, this one, this one, and this one. I will select the numbers. Wait just a minute. Roll number 10. Present or absent? Roll number 10. CRs try to respond. No? Roll number 10.
Absent, ma'am.
Okay. Roll number 25. Roll number 25. Roll number 25.
Ma'am.
Yes, ma'am. Tell me why not expression. Same like in 823 encoder, we have selected and where for which input this is highest. So based on this D1 plus D3 plus D1 plus D3 plus
D5
plus
and D7.
hmm,
That's it.
check once.
Okay, D9.
Okay, whether you have read what you said is correct or not, let me check. Yes, why not is you said D1, D3, D5, D7, D9. Yes. Now, roll number 32. Roll number 32.
Yes, ma'am.
Tell me the expression for Y1, ma.
D2 plus
D2.
D3,
Hmm.
D6, and plus D7.
Yes, good. Uh, roll number 37. Absent always. Roll number 36. 40. Roll number
Yes,
40.
ma'am.
Tell me the expression for Y2, ma.
Yes, ma'am. D4,
Hmm.
D5,
Hmm.
D6,
Hmm.
D7.
Okay, good. Hmm. Roll number 52. Roll number 52. Roll number 52.
Yes, ma'am.
Tell me the expression for Y3, ma.
Y3. D1.
Hmm. D8.
D9.
Hmm. So check wins, ma. So let me show, let me complete. Okay, ma, good. So say here, this is the expression y naught equals to d1 plus d3 plus d5 plus d7 plus d9. So this is for y1, this is for y2, and this is for y3. Okay. So finally, the last step is after completing this, go for, like we got an expression, next to go for logic diagram, circuit logic diagram. Now tell me, can anyone, how many OR gates will be used? How many OR gates will be used for decimal to BCD encoder? How many OR gates will be used, ma'am? This is your BCD block. How many OR gates? See here, I am showing you the circuit diagram also.
4.
Why there is a
4.
need of taking that much of time? Huh? How many outputs are there? 4 outputs. So 4 outputs means you will be getting 4 OR gates, right? Complete this logic circuit diagram. Huh? So for Y naught, what will be the inputs that you will pass for this OR gate? For Y naught, inputs that you are passing for this is D0, D1,
D3,
D3.
D5, D7, D9.
Okay. Complete the circuit diagram.